Hello students, today we are going to talk about Cauchy's linear equation. Okay, an equation of the form P naught x raised to power n dn y over dxn plus p1 xn minus 1 nth derivative of y n minus 1th derivative of y plus so on. Second last term pn minus 1 dy over x plus pny equal to qx, right? An equation of this form is known as Cauchy's linear equations. So obviously this is non-homogeneous linear, obviously, because it is being multiplied by with independent variable. So it is linear equation with variable coefficients, right? Because x sorry, I should have written x here because it has been multiplied with x, right? So therefore it is non-homogeneous linear equation with variable coefficients, right? So as we saw in the last video, okay, in last videos, 2-3 videos, we saw how to solve non-homogeneous linear equations with constant coefficients. Okay, now the we are little changing the equations, right? So we have introduced, okay, we want to solve such equations, such non-linear equations, okay, such non-homogeneous linear equation which involve variable coefficients. Okay, so this is one of them, right? So we will see how to solve these sort of equations, right? So firstly, we used to write them in the symbolic form. Okay, so symbolic form is p naught x raised to power n dn plus p1 x minus 1 dn minus 1 plus so on plus pn minus 1 x d plus pn. Okay, now outside y equal to qx. So this is linear equation with variable coefficients. So what is d here? D stands for derivation with respect to x, right? So if we want to solve these sort of equations, we used to do what? We used to change these sort of equations into non-homogeneous linear equation with constant coefficients. कैसे solve करेंगे? ये variable coefficient वाली differential equation को we are going to change into equations with constant coefficients. ठीक है, इसमें अभी coefficients variable हैं. अब हम कुछ ऐसा ट्रांसफॉर्मेशन लगाएंगे कि ये वाली इक्वेशन कांस्टेंट कोएफिशिएंट्स वाली इक्वेशन हो जाएंगी. ओके, सो हाउ टू डू दैट? सो in order to do that, we are going to apply this transformation or this substitution. Put x is equal to e raised to power exponential of z, right? So this implies z is equal to log x, obviously. So now wherever I'll be getting x, I'll be replacing it by ez, right? Exponential of z. So I should also replace the derivative like dy over dx. I should change these sort of derivative into these sort of derivatives, right? Because there will be no x, there should be no x in the above equation now. Okay, so see here z is equal to log x. So what would be dz by dx? It would be equal to 1 over log x, right? So what is dy over dx? हमें ये भी किस में चेंज करना पड़ेगा, ये वाला x भी z में चेंज करना पड़ेगा. ओके, so it could be written equal to dy over dz into dz over dx. So we know this is equal to 1 by x, so we can write it as 1 by x. Okay, in next step I'm writing, so dy over dx is equal to 1 over x dy over x, because dz by dx is equal to 1 upon x. Okay, so it is, so taking this x to the other side, we get x dy dx is equal to dy over dz, right? So this can be written equal to this. So you see, so with this we have consumed this x, right? We have second last derivative, we have changed a second last term into term with constant coefficient, because this term was here with variable coefficient. Now we have changed this term into coefficient term with constant coefficient. Okay, so we can also write it as, if so it is x dy equal to theta y, where theta stands for dy dz. Okay, so in short we can write x d is equal to theta. Okay, so see now what equation was there. Also moreover I want to write few more operator. Okay, so similarly, if you find out what is x square d square y dx square, it is equal to, okay, you will check it by yourself, it would come equal to, okay, x square d square y, it will come equal to d square y double derivative y with respect to z plus minus single derivative of y with respect to z. Okay, so this can be written as theta square, okay, y plus minus theta, right? So theta outside, okay, theta minus 1 inside, and here x square d square. So we can write it as what is your x square d square, it comes equal to theta into theta minus 1, and x cube d cube comes equal to theta into theta minus 1 into theta minus 2. Okay, so see what was your Cauchy's equation, right? So in this way we can write this as the theta, and this x will be consumed. Okay, next term here will be x cube x square d square. Okay, here also we can write theta into theta minus 1. Again you see variable coefficient has been consumed. Okay, so this goes on so on, like, right? So in this way we are able to convert differential equation with variable coefficients into differential equation with constant coefficients, and we already know how to solve the non-homogeneous linear equation with constant coefficients. We have done this in earlier videos, right? So we know this, we know very well how to solve these sort of equations, right? So this is the way how we are going to solve these sort of equations, right? Okay, now I'm gonna take few problems for you. Okay, so problem 1, Here x square double derivative of y minus minus 3x single derivative of y plus 5y is equal to x square log x, right? So again we can write this equation in symbolic form. Okay, symbolic form is x square d square minus 3x d plus 5, right, y outside equal to x square log x. Okay, so what we are going to do here, we are going to change this equation with variable coefficients into equation with constant coefficients. In order to make it equation with the constant coefficient, we will have to apply, okay, substitution. Put x is equal to exponential z. Okay, this implies z is equal to log of x. So therefore in when you substitute x by x equal to e raised to power z, we get x d is equal to theta, and x square d square is equal to theta into theta minus 1, where theta is equal to, theta stands for differentiation with respect to z, right? So in this way this equation becomes theta into theta minus 1 minus 3 theta minus 3 theta plus 5 y equal to, see now, x is equal to ez, so x square would be equal to e 2z, right? So here you are going to write e 2z and log x is equal to z. Okay, so I'm gonna write it here. Okay, z, this becomes z into e raised to power 2z, right? So solving this, okay, I get theta square minus theta minus 3 theta plus 5 z e to z. Okay, so it becomes theta minus 4 theta plus 5 y equal to z e to z. Now auxiliary equation, so we have changed this equation completely. Now this this equation which we got, okay, is non-homogeneous linear differential equation with constant coefficients. Okay, non-homogeneous linear है, differential equation तो है ही, with constant coefficients, right? तो इसके coefficients क्या हो गए, अब constant हो गए. तो we know it is pretty easy to solve. Okay, बस आपने यहाँ पे इतना ध्यान रखना है, यहाँ पे कोई x x कहीं है नहीं. Okay, we just have z in place of that. Okay, so this derivation is derivation with respect to z. Okay, so auxiliary equation बनाओ, इसका auxiliary equation is, this is already in symbolic form. Okay, if I write it can be also written in this way, like it could be written d square dz minus 4 dy dz plus 5 y equal to z. So x has been disappeared from this. Okay, so this is the symbolic form, this is the equation. Okay, now auxiliary equation is theta square minus 4 theta plus 5 is equal to 0, right? So let us find out the roots of this equation now. So roots are theta is equal to minus minus plus 4b, b is equal to 4, okay, plus minus b square 16 minus 20, right, divided by 2 times 1. Okay, so it is equal to 4 plus, and it is 2 iota, right, divided by 2. So it is equal to 2 cancel, so we get 2 plus minus iota. Okay, these are the two roots, 2 plus iota and 2 minus iota, so pair of complex number. So in this case, complementary function or solution is equal to, so what is alpha here? This is alpha, this is beta. Okay, so alpha plus iota beta, here alpha is equal to 2 and beta is equal to 1, right? So complementary solution is equal to exponential 2x c1 cos x plus c2 sin x, right? So this is your complementary solution. Now we want to find out particular integral. So we know particular integral is equal to 1 over, here it would be theta square minus 4 theta plus 5, right? It is z e 2z. Okay, so as you can see, we are having multiplication of two function here, e to z and z, right? So what we do, we can take it outside using rule number 4. Apply rule 4 here, which says 1 over fd exponential ax into v is equal to e ax outside 1 over d plus a v inside. So you can take it out, take 2 e exponential of 2z out and replace theta y, theta plus 2 whole square minus theta plus 2 plus 5 and here z only. Okay, now exponential 2z 1 over, it would be theta square plus 4 theta plus 4, right, minus 4 theta minus 8 plus 5. Okay, so 4 theta cancel, and you will be having minus 4 and minus 4 plus 5 1. Okay, so you get z here, you get exponential 2z 1 over, this is theta, right, theta square plus 1 and z here, right? So now we can apply binomial theorem. Now you are going to apply rule 3 here. Okay, where we change, we apply binomial theorem on the denominator of operator, inverse operator, right? So it is equal to exponential 2z, it could be written 1 plus theta square inverse theta, it is equal to exponential 2z 1 minus theta square plus theta 4 up to so on, because we are not in the need of this, because जब भी थीटा की पावर 1 से ज़्यादा हो जाएगी, ठीक है, तो डेरिवेटिव कितना हो जाएगा, 0 हो जाएगा, बिकॉज व्हेन वी डिफरेंशिएट z one time we get 1, if you differentiate this more 2 and more than 2 we get 0, right? So therefore we can write it as firstly z minus 0 plus 0. Okay, so it is again equal to z into exponential 2z. So this is your yp, this is your particular integral. So in this way complete solution is yc plus yp, and we know yc is equal to, what is your yc? Oh, I'm sorry, we wrote e raised to power 2x here, right? It must be e raised to power z, e raised cos z sin z, right? It is yp, right? So yc is e raised to power 2z c1 cos z plus c2 sin z, right? Plus z exponential 2z. Okay, now nextly we are going to change this z. Now we are going to substitute back ez equal to x. So in this way you get x square here and c1 cos of log x, okay, because z is equal to log x, plus c2 sin log of x plus z is equal to log x and e to z is equal to x square. So this is your solution. Okay, this is the way how we solve Cauchy linear equations, right? Okay, in this case coefficients of differential equations are variable. Now I'm gonna take one more problem. Okay, second problem P2. Solve x square y double dash minus 3x y single dash, okay, plus 4y equal to 2x square, right? So it could be also written as x square double derivative of y minus 3x single derivative of y plus 4y is equal to 2x square. Okay, in symbolic form we are going to write it as x square d square minus 3x d plus 4 y outside equal to 2 e 2x square, okay, 2x square, right? So now we are going to change, we are going to put x is equal to exponential z. This implies z is equal to log x. Okay, so in this way we get xd is equal to theta and x square d square is equal to theta square theta into theta minus 1. Okay, so replacing this in this way, this equation becomes theta into theta minus 1 minus theta plus 4 y equal to 2. Okay, x square, x is equal to this, so it becomes exponential 2z, right? So now theta square minus theta, okay, fine, it was 3 here. Okay, minus 3 theta plus 4 y is equal to 2 e2z. Okay, so theta square minus 4 theta plus 4 y is equal to 2. Okay, so auxiliary equation is in this case theta square minus 4 theta plus 4 is equal to 0. So roots of this auxiliary equation is theta is equal to 2 comma 2. So in this way complementary solution is c1, okay, e raised to power 2z plus z into c2 e raised to power 2, because we get repeated root here. Okay, so now complementary solution complementary solution is done. Now particular integral is theta minus 4 theta plus 4, okay, 2 time e raised to power 2z. So 2 outside Okay, so we get theta square minus 4 theta plus 4 e2z. Okay, so now if you apply rule 1, what does it say? That when we get qx is equal to e raised to power az, do what? Replace d by a. Okay, okay, so in this case, when we get qx is equal to ex, we replace d by a. So here a is equal to 2, so we are going to write 2 square minus 4 2 plus 4, which is equal to 0. So this is equal to 0, so which is the case of failure. So what we do in that case, we differentiate this thing. Okay, so and write z outside, so you get 1 over 2z and differentiation with respect to theta of theta square minus 4 theta plus 4 e2z here, right? So now it is equal to 2z, so here you will be having 2 theta minus 4. Okay, e2z again. Okay, put, replace. Okay, again by rule 1 we are going to replace theta by 2. Okay, so we get 1 over 0 again. Okay, so we are again going to differentiate the denominator with respect to theta again, and we are also going to multiply with z again. Okay, so in this way we get 2 d by d theta of 2 theta minus 4 e to z. Okay, so after differentiation it would be 2 in the denominator, right? So it would be 0, right? So e to z, so 2 cancel, so we get, so in this way this is z square. Okay, I mistakenly wrote it ez. Okay, so we get z square e to z is the yp. Okay, so complete solution is yc plus yp, and what is yc? c1 e raised to power 2z plus c2 z e raised to power 2z, and your yp is z square 2z z square e raised to power 2z. Okay, so we know the substitution. Okay, so it replacing back. Okay, substituting back, we get c1 x square plus c2 log x into x square plus, this is equal to log x whole square, and this is equal to x square, because x is equal to ez, and z is equal to log x, right? So in this way we get solution c1 plus c2 log x square plus x log x whole square. This is your solution. This is the way how we solve Cauchy linear equation, right? So I think this is it for today. In next video we are going to take some other topic, right? Thank you.